Hi, my name is Vladimir Korkhov and I'm representing the University of Amsterdam Grid Workflow Group. I'm going to tell you about the WS-VLAM workflow system that we develop and about the tools we create for it. WS-VLAM is a grid workflow system, so it means it can compose and execute the workflows on the grid. We use it for a number of applications, so for example for a human transcriptome map and for some DNA analysis. And the system itself consists of workflow composer and the main part, the workflow engine, which is designed using the Globus Toolkit 4 technologies, and it uses many standard features of it. We also use the workflow monitoring during the runtime, so it's possible to get the information from the running instances. The composer supports drag and drop composition, and it's possible to create hierarchical workflows and also to attach and detach the composer, the graphical user interface, from the running workflow. We have different tools to support the composition and execution. So the first one is the tool for creating workflow components. So with it you can create the special description files with the ports and the parameters of the modules. The ports are used to connect the modules during the runtime, and the parameters can be set before or during the execution by users. Another tool is a web service harvester. It can be used to turn web services to workflow components and to be used inside the workflow. We use also the tools for semantic annotation of workflow to describe the modules semantically, and also to match them for the user requirements with the matchmaker. This is a typical scenario for a demo. Client has all the WS-VLAM software. The eLab server runs WS-VLAM server software, the engine and the repository, and the modules can be executed through this server on the computing clusters. Now for the demo itself. So we start from going to My Experiment web page and search for the Cygwin experiment. So this is the workflow that has been created using the WS-VLAM composer. So here it is, and now we can load it to the WS-VLAM composer right from here, from this page. So by clicking, we start the Java Web Start application, which is the composer. Now it will show up in a couple of seconds on our screens. Here it is, with the workflow from My Experiment there. Now we can check all the settings for the modules. So for example, here we can see the parameters for this workflow component. In this case is the file name for the input data for the reader module. Next step is to delegate the credentials to the delegation service. So we create the proxy and then delegate it. And then we get the response from the delegation service. Here it is. Now we are executing the workflow. And we can see that the monitoring window has popped up with the information about all workflow components that are in this workflow. The default tab is about the state of the whole workflow, and each tab then is responsible for the information about each particular module, with the standard output, standard error, and status tabs. So now we can check the status of the execution of one of the modules. we get some information from GRAM, and for each module we can check the status and the messages from the application itself. Now it's the time to check the graphical output, basically the result of the workflow. Here it is. So this is the result of our distributed computation. So that's it. Thank you.